now in this video we're going to look at some voltage dividers quickly. So this is the next video of my Learning Electronics Quick video series. We have 5 volts at the rail there. I try to introduce these topics as quick as possible, and you can look at them in more detail later on if you want to. But in any case, here's one of the voltage dividers. All of these fixed value resistors here are equal value. They're all 1 kilo ohm. And so there we have 5 volts across it. We lost a little bit of voltage from the wires and whatnot, but this is not a precision circuit. Main takeaway is, at this point, we have half of the power supply voltage. And that's because half the resistance towards the negative rail, half the resistance to the positive rail. And so you get a voltage there. So of course a load will throw that off. Usually you feed that voltage to something that doesn't need current, like the multimeter. It will look at that voltage and do whatever it's going to do with it. So now we come to a 3 resistor version of this. So again, we have the power supply voltage across them, but in relationship to ground here, if I go here, there's more resistance towards the negative rail, less to the positive rail, and so we're going to have about 2/3 of the power supply voltage right there, as you can see there. That's because these are equal value. If I come over here, then we have 1/3 of the power supply voltage. So we could use a 1 kilo ohm and a 2 kilo ohm resistor, get the same result there, or we could use a 1 kilo ohm resistor there and a 2 kilo ohm resistor here to get that result there, the 2/3 voltage. It's proportional. It's how much resistance is towards the positive rail versus how much is to the negative rail. But these equal value resistors make the math easier. So now, fixed resistors work great for some circuits. I use this one all the time for the op amp, but with 100 kilo ohm resistors. And the internal operations of the 555 timer uses 3 fixed resistors like that to get 1/3 and 2/3 power supply voltage. I have an alligator clipped to that jumper because here with the potentiometer, this is called a trimmer potentiometer or a trimpot, we have one resistive element that goes from the one pin on the top to the other pin on the bottom, and the middle pin there's a wiper, and so I got each one of those to a jumper. That is the middle one there. So in relationship to ground, I'm going to add an alligator clip to the probe there that I crimped a wire to, and we will see that when I connect here, it's about halfway. We have about half of the resistance, and this one, it's large enough you can easily turn it with your finger, or you could use a screwdriver. In the slot there it has an arrow, so now it's pointing about halfway. Now we go all the way, it's pointing to that jumper there. We have the full power supply voltage minus a little bit because there's little resistances everywhere, but here we go all the way. We got absolutely 0 according to the meter. It may have a speck of voltage on there or something. This is not precision. We can be slightly off, but in case there you can see we can easily adjust that, or you could have an adjustable resistor on one end or the other depending on how you want to have the resistance. And so in any case, that's it for the quick summary. I'll pop up some more videos on here, and also a subscription button. Make sure you subscribe and click the bell to watch every video I upload. That would help a lot. Thanks for watching. I will see you in the next video.